Okay. The picture for number 33 is two consecutive angles, I think. Yeah. So you have this transversal, MN, and 1 and 2 are those two angles. All right, so let's go through the process of what you're supposed to be doing. You're supposed to be proving that M and N are parallel. And we have angle 1 and angle 2. Now, those are consecutive angles. So if we know that they add up to 180 degrees, then we know they're supplementary, which means they're the consecutive angles consecutive interior angles converse theorem would make this parallel. This is what you're supposed to do on every proof problem. Walk through what is in your picture, look at your given, and by the time you're done with that, you should have an idea of what you need to do in the proof. Now, you may not exactly get the proof right, but you should already in your own mind know that there's a path to take to prove this. All right, now this one is actually probably the hardest out of the four problems. So the given is that angle 1, the measure of angle 1 is 115 degrees. All right, angle 1. And angle 2 is equal to 65 degrees. All right, so that should be the first thing we do as we look at the given is mark the picture. And sure enough, we know that 115 degrees plus 65 is 180 degrees. So therefore, these two lines are parallel because those two angles are supplementary. So how do we get that on paper? My point to you is, those of you who left it blank, first of all, shame on you for not even looking in the back of the book. Those of you who looked at the back of the book, okay, good. Did you learn anything? So let's point out some things that you should take away from this. Okay, again, remember, proofs aren't a big majority of geometry. Okay?
Thank goodness.
Yeah.
I'm dying.
So we have the given. Notice what they did here. They created an equation, which is something you probably would not have thought of. That's why I think this is probably the harder problem out of the four, because you just don't think of stuff like this. So the measure of the two angles is equal to the measure of the same two angles. That's reflexive. And this is kind of a tool to use for future purposes. Because now I can actually substitute the degrees into one side of the equation, add like terms together, and now I have the supplementary reasoning here. So you could have done part of this yourself because you do have the given. You could have said, well, measure of angle 1 plus measure of angle 2 is equal to 180 degrees. You could have skipped all of this, and technically, you know, you shouldn't skip that, but you didn't know to do this, all right? You were looking at this and saying, well, I can show the measures are equal to 180 degrees. At the very minimum, you could have done that. You should have done that. Because once you get to here, then the angles are supplementary by definition of supplementary angles. And if they're supplementary, which is what we said at the beginning before we started, then by the consecutive interior angles converse theorem, the two lines are parallel. So this part right, see the given, you should have had, and you should have been able to get to here. And just didn't realize, well, how do we create an equation? Or why do we even need to create an equation? For me, this would have been okay for you guys. But I didn't see very many people do this. All right, so that was the harder of the four proofs. Let's take a look at the other three. So 34, you did not have the answer in the back of the book. The picture of 34 is two parallel lines cut by a transversal, 1, 2, and 3. and we are trying to prove that M and N are parallel. So before I even look at the given, I notice that we have vertical angles and we have consecutive interior angles. So obviously, to prove that these two are parallel, I'm going to have to show that these two are supplementary and use the consecutive interior angles converse theorem. Everybody in here should be able to do that. We've been spending all week on these 4 theorems. So let's look at the given. The given says angle 1 and angle 3 are supplementary. So angle 1 and angle 3 are supplementary. All right, now we can even start to think even further. Angle 1 and angle 2 are congruent. I don't say equal, because that means you know their degrees. Now when you say equal, I know what you're saying. Angle 1 and angle 2 are congruent because of vertical angles. Well, if angle 1 and angle 3 are supplementary, then I can say angle 2 is supplementary to angle 3 by the transitive property. And then you have supplementary angles, you have the consecutive interior angles converse theorem. So again, before I even begin the proof after the given, I should already have an idea of the direction to go. Okay, so the next thing is what they did is they showed that if they're supplementary, then their measurements are equal to 180. So now we have an equation. And then we said that angle 1 and angle 2 are congruent because of vertical angles, so their measurements are equal. So once we introduce an equation, we need measurements to plug in. We can't do substitution here. This represents the picture, this represents value. Remember we talked about this in chapter 1. So I can't really change the measure of angle 1 into the measure of angle 2 until I say I have the measurements. And because they are congruent, they therefore are equal. And now I can substitute. So this is not the transitive property, it's substitution, because I'm putting something into an equation. So hopefully you're starting to see the differences between transitive and substitution. If you're replacing something in an equation, that's substitution. All right, so once you've done that, then the measure of angle 2 plus the measure of angle 3 is 180, that's substitution. So if they're equal to 180, then angle 2 and angle 3 are supplementary by definition of supplementary angles. And that's what you wanted. Angle 2 and angle 3 are supplementary. So consecutive interior angles converse theorem says that those two lines are parallel. Got it? Yeah. Okay, let's look at the next problem. This is a weird picture. You had this also in the back of your book, so if you didn't understand it, pay attention. Again, I'm going to walk through it. First period I walked through it with everybody without looking at the answers, so I'm just showing you exactly what you should be doing. This weird picture happens to occur in the book quite often. 1, 2, 3, and 4. Okay, so I see vertical angles here. 1 and 2 and 3 are vertical angles. As I start, we're trying to prove that AB is parallel to CD. So let me put some big lines on here to help you understand what we're looking at. So we have two different transversals here. All right, so the transversal we're really looking at is the one with all the numbers. Again, I'm not looking at anything else yet. So here's the transversal. I see alternate interior angles, and I see vertical angles. Again, at this point, I have to show that angle 1 and angle 4 have to be the same. That's the only thing on here that'll tell me that we have parallel lines. Correct? Okay, so let's look at the given. Angle 1 and angle 2 are congruent. Angle 3 and angle 4 are congruent. So really, I would do this because there's nothing that says they're equal until I say angle 2 and angle 3 are congruent. because of vertical angles. And that's exactly how they started. So therefore, they all have the same lines. So angle 1 is to angle 2 is to angle 3, so angle 1 is to angle 3. That's the transitive property. Angle 2 is to angle 3, and angle 3 is to angle 4, so angle 2 is to angle 2 is to angle 4. That's the transitive property. All right, and angle 1 and 2, those are the same. So angle 1 is to angle 4. Therefore, alternate interior angles converse theorem. Okay? Guys, you have to try. Okay? You can't just say, that's proof. I got everything else. I'm not going to do that. I'm going to keep making these worth more points. You have to put forth some effort. Everybody in here could do something on there. You do something. Don't leave it blank. That just tells me that you don't care, you're lazy, or you absolutely don't know because you didn't care and were lazy. So let's take a look at this one. This is a crazy problem. You have A and B, and you have C and D. And 1, 2, 3, 4. 1 and 2 are corresponding, 3 and 4 are consecutive. Or 2 and 4 are consecutive if we're looking at the different sides. So we need to identify certain things. What have we been given? A and B are parallel. Okay, so that helps out. So that goes back to section 2, knowing you have parallel lines. So if these are my two parallel lines, on this transversal, angle 1 and angle 3 are congruent because of alternate interior angles. Not the converse. We already have the parallel lines. And these two, with this transversal, these are consecutive interior angles, which means they're supplementary, not equal. Okay? So what are we proving? Oh wait, 2 and 3 are the same as well. So that's a given as well. And now looking at this, I can prove that C and D are parallel because you have corresponding angles converse theorem. So what did they say? One and 3 because of alternate interior angles, we said that. And then 1 and 2, of course, transitive property. 2 to 3, 3 to 1, so 1 is to 2. And then you have the corresponding angles converse theorem. I'm not saying that you're going to write it down exactly right, but you definitely should have an idea of how to get to the answer. Okay? All right, journals. Section 4.
Are even more boring than cleaning my room.
So page 83. Page 83. Okay, so these are going to be harder to remember the names. So again, you're going to have to do something on your own to remember this stuff. Linear pair. What do you know about linear pair before we do anything else? What's a linear pair mean to you? They equal 180. Keep going. Just in general. Not a trick question. They have to be attached, and they form what? Straight line. Okay. So then what does perpendicular mean? Two lines that meet at right angles. What's a right angle? 90 degrees. So you just realize that when you say linear pair perpendicular, you are saying a whole bunch of information instead of having to write all that stuff out. So notice there's no squares here showing that they're perpendicular. That's what you're trying to prove. It says that if you can show that angle 1 and angle 2 are congruent to each other, then you can say that these are 90 degrees because of the linear pair perpendicular theorem. If there's no box there and it doesn't say that they're 90 degrees or perpendicular, you have to, and you know that they are, you have to prove that you know that they are. Once you prove that they're congruent to each other, because there's going to be a reason that they don't put a box on it. Once you prove that they're congruent to each other, then you can say, then they're 90 degrees because of the linear pair perpendicular theorem. You got to remember the words. You do not get a bank of these on chapter 3 test. You have to do something to remember. Down here, perpendicular transversal. So if you have two parallel lines, notice they are parallel. You're not proving they're parallel. You have two parallel lines cut by a transversal, and the transversal hits one line at 90 degrees. It therefore hits the other one at 90 degrees, which makes sense, right? Because if you have parallel lines, then corresponding angles are equal. So I actually just went through a proof of how you prove that theorem. Does everybody understand that? If it's perpendicular to one parallel line, it's perpendicular to the other. You're going to have a whole bunch of problems that look like this today. Okay, you got to say the theorems. All right, perpendicular transversal. We're almost done. Lines perpendicular to a transversal. So you see how all three of these kind of mix together? If you don't practice going over these, if you just wait till right before the test, you're going to screw this up. Lines perpendicular to a transversal. Notice there are no parallel markings on the two lines that we think are parallel. So we're another theorem to help you prove the two lines are parallel. So you had the four that we had written up here. Now you have this one. So if the two lines are both perpendicular to the transversal, they therefore are parallel. How would you prove it? You'd have to say, well, by the definition of perpendicular lines, this measurement of this angle is 90, the measure of this one is 90, so they are equal to each other, and by corresponding angles converse theorem, those two lines are parallel. That would be the proof of this theorem. And the proof of the theorems are pretty simple. They don't have to be really long. So if you know that those two angles are equal, whether they're 30 degrees or 90 degrees, it's the corresponding angles converse theorem. But if they're 90, you can use lines perpendicular to a transversal theorem. Because they're not putting up any measurements here. Okay. What does it say here? Distance. What does that mean? Distance for an... All right, here's your assignment. I'll put it on Google Classroom.